session today on the US Census. So this session is going to be recorded. So we'll make the recordings available post this event so that you can share with others, come back and catch things or catch sessions that you weren't able to attend. So I'm Amy Work, I'm the GIS librarian at UC San Diego, and I have with me Danielle Kane from UC Irvine and Erin Much from UC Merced as sort of a helper and as a Zoom host. So if there's any questions, technical, you can chat to one of us, but we'll go ahead and get started. We have five wonderful speakers today, so we're excited to have everyone talk. We'll go ahead and get started. If there's questions at all while we're going through, you can put them in the chat. You can chat them to everyone if you would like, or you can chat them directly to one of us or to the presenter. I'll say it's easier if others can see the questions, but feel free to do whatever you're most comfortable with. You'll also see in the chat that we've got the Slack space that you can follow up with questions or conversations during or post as well. So we'll go ahead and get started. And so if there's any questions, put them in the chat, but we're excited to have all of you and let's go ahead and get started. So our first presentation is Amanda Recinos from GreenInfo on tips for getting started with the Census API. Since the early 2000s, Amanda has been a geospatial analyst at GreenInfo Network with a focus on demographic data. Her projects often involve obtaining, summarizing, analyzing, and presenting information about community characteristics. Amanda, go ahead and take it over.
All right, first question, are you hearing me and seeing my screen?
Yes, we can see your blue screen.
Okay.
So just the window.
Let me change that. Now are you seeing it?
Yes, we are.
Okay, let me find my speaker notes and then we'll be ready. Okay, so I am Amanda Recinos, and I also have a coworker with me that I'll introduce in a moment. But I just want to be upfront in the beginning about exactly what we'll talk about. We use the census information. We are not from the Census Bureau, but we find their information, the way it's available in the data, very helpful to our work. So today we're going to walk through what we've learned using the Census API to get data. And we're specifically going to focus on the American Community Survey. There are others that we'll talk about. Most of what you'll learn would be applicable to those also, but these examples are specific to the American Community Survey. All right, so as I said, I'm Amanda Recinos. I also have Jaida with me. She'll be helping out when we get to some of the later slides. She did a lot of the background work and documentation and learning up as we went through this process, so she'll be helping me present different parts. So we frequently work together on projects where we're bringing information from the Census Bureau in to inform either maps or tabular summaries, sometimes in reports. So that's what we'll be taking our learning from and hopefully sharing tips and tricks and things that can help you either get started or advance what you've been doing. We are making the slide deck available after the presentation. Should you be interested, it will also have speaker notes, and I believe that they're being recorded and shared later on. So this slide is going to serve as both a bit of an agenda for today, but also the steps that one needs to go through if you're interested in using the Census API. So the first 5 are the ones that are necessary. The bottom 2 of aggregation and joining are a little bit optional depending on what you're going to be doing with the data. So we'll go ahead and start with 1 and walk through the first 5. If there's additional time at the end or questions, we can cover a bit more on aggregation and joining of the data if you're going to be using it in other software, but we'll just sort of see how much time is available when we get through the rest. So the first thing that was noted on the slide that you need to do is to understand the geography that you'll be working within. And so the Census Bureau has a number of different geographies. The main ones that we tend to use are what I consider sort of the main geographies that we have shown here. So in this example, we would be saying that perhaps you wanted to look at the state of California, but within, so we have the nation and or the territories of the US. Those are broken down into states or territories. We then have counties within the states. Those break down into block groups, and then those are further broken down into blocks. So this is the tiger geometry that the Census Bureau uses. Now, if you look at this sort of in the reverse order, there are what we call nested geographies. So that means if you look at the block level over here on the far right, There are typically about, I think it's 8 that are combined together and dissolved, and that becomes your next level up, which is your block group. Those are then clustered together with surrounding and similar block groups that build to your tract. Tracts then build up to a county, so they do not cross county boundary lines, and then those build up to your state. So that's the overall geography for this main level that goes down the middle that I'll show you next. The important thing about this is that you can look at the entire US or a territory from wall to wall. So there may or may not be population in parts of the state, but the tiger geography does have full coverage of the United States and territories. So to make that a little more clear in a different graphic from the Census Bureau, we have this center line. So these are the ones we just showed on the previous map, where you start at your nation and then you can break down into regions, divisions, states, counties. I didn't put regions and divisions, but they're subsections of the US. And then all the way down to the block. So these are what I consider the main sort of nested geographies of the Census Bureau. Off to the side are these different elements. Now, a lot of these are probably not as familiar or as important to folks, but a few are. And a main one that comes up is places. So this is often more fully referred to as a census designated place. And that is incorporated cities or places, which you might think of as a town, that are not officially incorporated, but have a large mass of population. It's all documented online and you can pick between the two. But as you'll see on this graphic they've shown, those fall entirely within a state. So if you were to pick a place or a city, it would fall entirely within a state, but it does not always fall within a county. So it could cross a county boundary. Likewise, if you were to say, I want to look at all the census tracts, those edges are not going to agree with your city boundaries. So it's important to think about, are you looking at presenting information about a city, or are you looking to cover a full area that may or may not cross jurisdictional boundaries? Another common one, particularly in health fields, I find are zip code tabulation areas, which are not exactly the same as zip codes, but quite similar. So the main thing with these, and in particular places, if you were to look at, say, all of the places in California, you're going to have large holes. So those are areas where you don't have an incorporated city jurisdiction. So you want to think about if it's important for you to have full coverage across an area, in which case you probably want to try and stick with these main geographies, or if you instead just want to represent numbers by a jurisdiction. As a general rule of thumb, I like to stick to these middle ones and maybe supplement with something off to the side if I want a different like school district summary. You can do that. And then also in terms of how to pick between these different ones, if you're looking at something that's a subdivision of a state, so something smaller or more zoomed in than a state, I generally like to start with considering the tract level and the block group level and deciding between those two. It's a general starting point, but you really have to sort of consider all the different things we're going to go through. So we're starting with geography. We'll next move to 2 other elements. So you have to sort of bring all these decisions together. So let's go to the next one. So the next thing is the Census Bureau has a number of products available, actually quite a large number. The 2 that are the more common that you've probably heard of are your decennial census. We just had one in 2020, but there's also an ongoing rolling American Community Survey. And in this one, they have a couple of different versions on years. I know they have the 5-year, and I think maybe just the 1 year, and they did away with the 3-year. I can't recall exactly, but between these 2, there are pros and cons in terms of which you want to select. So the census 2020 is great because it's an actual full count. So they're actually mandated to count each person as much as possible. Whereas the American Community Survey, they're putting out estimates. So they're polling a certain population and then factoring up to try to figure out how that would play out across the whole nation. So you have actual counts versus estimates. A limitation is that they don't really count a whole lot of information at the full level anymore. It's gender, age, and race ethnicity, I believe, are the only ones currently counted. So if you want to know anything other than that about your population, you're simply not going to be able to use this decennial census. Back in 1990, they had a lot more, but from 2000 on, it's become quite limited. An advantage is you can get very fine levels. So the block level data is available, which is our smallest geography, as we saw in one of the early slides, that is not available in the American Community Survey. And then the last one I have listed here is your time frame. So it's hard because sometimes this plays in your advantage right now because it's very recent. It just came out. But 8 or 9 years from now, when we're just setting up for the next census in 2030, the data will feel quite stale or dated. So you really have to think of where you are now in relation to the time frame of the data. On the American Community Survey side, there are huge numbers of variables available to you. So that's a great thing. In terms of geography, you can only go down to a block group. You cannot get block level information. And then also an important thing, and this will vary from variable to variable, but some have what are considered a high margin of error. So that's where they're getting inconsistent results or low levels of reply. So there are times where they're reporting information that is a little more ambiguous than you would hope. So in addition to these two APIs, which is what we're going to go into in a few minutes about extracting the data, there are many others. We'll focus today on an ACS version, but there are many other surveys, and this link here would get you there if you're interested in the future. So at this point, you would pick your variable or your geography, you would pick your survey, and then you want to figure out what variables you're interested in knowing more about. So assuming we're using the ACS data, these are some of the more common ones that we use. There are hundreds, probably thousands. This link would show you all of those available for any particular year that you're interested in. It's also important to think about now you have to start to bring your decisions together because some information is not available at all geographies. So there are going to be block groups. So at the ACS, the most detailed level would be a block group. There will be block groups that do not have median household income data. So you need to consider if that's okay for you or not. Can you have no data areas, or do you want to pull up to a tract and see if you can get them there? So you have to sort of consider all of these within each other because there are relations where you might have 2 out of the 3 things available, but you need all 3 in order for your request to work. So the actual sort of substance of this is, okay, how do I actually get this data? Previously, you may or may not have used the American Fact Finder. That was a more of a GUI interface where you're clicking buttons. The Census Bureau does still have that. It can work well if you need limited information, but we find the API, despite looking a little overwhelming at first, is quite user-friendly. You get a lot of information. It's very quick, very reliable, and really very flexible. So what I want to do is walk you through an example of how this is constructed, what these different pieces mean, so that you can not only understand this one, but start to create your own or modify ones that you find out there that are almost what you need, but not quite getting you there. So this is where we're bringing our 3 elements together. We've selected our data set, we've selected our variables and our geography. So these are the key pieces that we walk through so far. So think of this as you're going to formulate a series of 3 pieces of information. You're going to put that all into a formatted URL and then send that to the system. And then when you hit return, it sends you back your data. So first step, when you enter this in your bar for your website, you're just simply this first part in black, you're just going to the right location on the web. The next element you're entering is what year of data are you interested in. So a great part is we have the most current data, but you can also go back in time. There are previous ACS surveys that are available. So if you want to do time series analysis, that's readily available. So in this instance, we're saying, okay, we want information from the American Community Survey, and that's embedded within what we're calling here, and we want it for the year 2018. Now we're doing a 5-year ACS survey, and you're always picking your last year in the 5-year of a series. That is true of all Tiger data and census information. But to make that more clear, the next part is you are now also saying, okay, so I want 2018, but I want it to actually be the 5-year 2018. So that will be your 2014 to 2018 5-year survey. So this is simply appended. I'm going to the ACS and I want the 5-year. The next part is the variable. So in this case, I'm saying I want to know the total population. This is sort of a topic or a group, what used to be considered an independent table that's reporting basic population information, statistics on how many people there are. You can enter one or many of these within your same request, and we'll go over that in more detail. But for this first one, I want to keep it as simple as possible, showing just one. You can request up to 50, and there are other ways to do more than 50 that we'll talk about also. The last element is, okay, I want to be, in this case, looking in the state of Montana, because that's their FIPS code 30. And so my largest bounding geography is I want the entire state, but I actually want tract information for it. So in this case, we're going through all of the ones we previously did, and then we're appending. We want to know the tract, and this asterisk here is saying every single tract within the state. You could limit it if you wanted to list just one or two. And it's within the state of 30, and this is your FIPS code for the state of Montana. So once this is built in your URL, you will click enter, and this on this hand side is what is returned to you. So this was the variable I called, which happens to be total population. And then it's also returning to me the FIPS code. So my state, again, I entered 30. You can confirm here that indeed is what was called. Because I want tracts, they're all nested within a county. That was shown on one of the first slides. So you can see within here, you have your 3-digit FIPS code for each county that's being reported. And then your tract number is added here along the end. Now, an important thing is that these will be returned to you with the columns consistently ordered. The rows are not. So that's to say, if I made this API call and then I turned around and did a new one, and instead of this, I put in a different value, these rows will shift. They can, they might, you don't know. So it's really hard to stitch data back together. For that reason, we recommend, if at all possible, listing all of your variables in one URL. That way you know that you're never mixing up your tracts or census blocks or things that could be returned to you. The nice part is it's really easy. So now you have your API call here. It remains in your browser window, and you have your results. So if, for example, in this, you thought, well, I'm interested in Montana and I have my 2018 data, but I also want a table that shows me what was the case of population in 2016. All you have to do is modify just straight up here. You would change your 8 to a 6, hit return, and this will refresh and update. Most times I find it nearly instantaneous how quickly the data is returned. Let's say you were working for a week or two and then you thought, you know what, I actually need to add the state of California. You could use your same API that you had originally done with 2018 and simply change your state. You would then say, what I'm asking for are all the tracts within California. Give me the population for 2018, which is the 5-year survey, compiled survey. So the last example here is the one I mentioned, that you can bring in more than one variable. So the initial one that I've had here is total population, but I could also say, you know what, I'm interested in income data. So in this case, I'm saying going to the income table and return this value within it for me. So all you do is add this and symbol to concatenate those together. So I recommend you do your first URL construction, you write it, and then simply tinker with it until you get the exact results that you're hoping for. So once you have it, it is still in your browser window at this point. So the next 2 steps are going to be to download that and do some cleaning. So I'm going to hand it over to Jaida for a few quick slides for her to go over those steps.
Hi, everyone. So as Amanda mentioned, all the data we've seen so far is visible in a browser window, but for it to be useful, we want it in a tabular format. And it's pretty straightforward to get from the browser to that step. So right-click on your browser tab and save your file as a text file with the .csv extension. CSV stands for comma separated values. And so you can see in the screenshots, we start with a web browser, but then once it's saved as a CSV, you can open it in a regular text editor and just replace the square brackets. You're not replacing them with anything, not even spaces, you just essentially remove them. And once you save this, you can open it in a spreadsheet application like Google Sheets or Microsoft Excel. And if you're familiar with the JSON data format, this is all in JSON. So if you're doing this programmatically or you have tools, you could also use a JSON to CSV converter. But as a starting point, this is a pretty straightforward way to go. And a few things to be mindful of. For the most part, this process is straightforward, but there are a few gotchas. As Amanda mentioned earlier, if you wanted all tracks in a state, you could just say tracked : star. Block group is the one exception where you have to specify the counties you want them from. So you have to add, as you can see in the URL, the FIPS codes for counties, and you can have several listed at once, but they have to be specified. You couldn't get all block groups in a state. And you could extract the official name of that geography as well. But as you can see in the screenshot, the text here, it has commas. And so if you're using the CSV format, these commas can break formatting. So a recommendation is, unless you really need the name, don't download it, or be mindful of how you clean up the commas in there. And again, if you were using this data to join to the Tiger shapefiles, which have the polygons for each geometry, you're going to need the GeoID. And the GeoID is just a numeric format that represents that specific geography. So the 3 columns you see on the right, state, county, and tract, you could combine all of them, including the zeros, to get the GeoID for these specific rows. And that's the format of the Tiger GeoID. So in your spreadsheet application, if you combine these 3 columns, now you have a field that you can easily join, that you use to join the data to Tiger. You could also extract the GeoID from the URL directly. So if you look, the first column on the left is the GeoID we get from the Census API, but it has a few extra characters up until the US. So if you were using these, you'd have to make sure to just strip those out. And always remember to save your GeoIDs as text, because if you see, many of them have leading zeros, and it's easy to trip up when they become numeric and lose the zeros, then things don't match. In some cases, the data may also have empty values or error codes. It's good to keep an eye out for it. We have a link here on what the error codes look like. And this comes into play if you are going to do any mathematical operations on the data. So if you were going to sum up 2 columns, for example, and the error code is negative, you don't want that being treated as a data value. So you could replace that with 0 if you needed to do any math on it. And if you did want block level data, as Amanda mentioned, ACS only goes down to the block group level. For block level, you have to use a different API where the URL varies and the variables as well are named differently. So it's a little bit of more work to generate that. And back to Amanda for this slide.
All right, so some of the higher level tips we've learned as we went through this learning process, and I'll try to keep these quick, is save your URL. So if you make a request and you find everything you want, it's really nice just to text file or even in your table, save the actual URL you use. That serves as great metadata. It gives you all the information you need. I personally like to start from an existing URL and edit versus starting from a blank window. It's much harder for me. The Census Bureau provides them, or I save my own that are very common. And then you can just start editing from there. If you previously used data from the census, you used to have to pull individual topics or tables. That's no longer required. You can now pull across all of them equally. If you find that you're making a lot of requests, which I think is more than 50 variables in any one call, or 500 queries, I think, a day, you can just request a key from the Census Bureau here. It's very quick and easy. You send them a note, they send it back, and you attach it to your URL, and that opens your limitations. We also have been starting to think about the pandemic. The 2016 to 2020 was just announced that it will be delayed. It's not going to be released in December. Instead, it will be March of next year. And then we also know there have been population shifts and movements and changes, and surely there will be things that we don't anticipate. So make sure you keep an eye out in the future for articles and news on that to make sure that you're up to date with how things are changing. And then further in the timeline, In 2025, there is the possibility that the Census Bureau will start enacting differential privacy, which this essentially means introducing some noise or errors to the data. And this is, it would be done in order to make sure that someone could not go back and extract who answered what questions how. So it's a privacy concern. It's a little unclear the path forward, but our pretty clear understanding is that we don't have to worry about that until 2025 in the ACS. The next ones are probably ones you would just use offline, but worth noting, we have generalized, obviously, a lot of this information here just to give you the highest level. If you need more info on the API, there's great census information available. I normally start here and find just about everything I need. And then also, if you use other libraries from R or Python, there are great ones that we have linked to here. If you want cross-tabular information from multiple topics being reported, so you want to merge together your variables, iPooms is a good offering. It isn't, I think it doesn't go down very low in geography, so you wouldn't be able to get block level data. But if you're not quite finding the variable you need, you might look here. And then also, if you want historic data, some of it is on the API, like I noted, but if you want to go very far back in history, the NHGIS site is fabulous. They have both the attributes and the geometry, so you can work with both of those. And then also, if you're sort of wondering where to start, these are two great links after the presentation where you could go. Like I said, they have these example calls. So you could simply just put this into your browser window, click return and see what happens, and then start changing things and see how that all works. They also have the documentation. There are lists for every year, what variable is available. You can scroll through those. And then within those, you can see the very detailed information about what's available, including, as I said before, the margin of error. So if you start to feel your data just doesn't seem right, check and see if your margin of error is high. The Census Bureau has tons and tons of information and documentation and always very responsive. So reach out if you find you have questions. And again, they also list a lot of these great sample ones. And this is where you would put your key if you have one, if you're making more than the 50 or 500 requests that are limited. So with that, I want to be mindful of time. I think we were a little bit long, so I apologize for that. But, you know, the API is great. It'll take you a little bit to get started, but we think it's well worth your time to invest that upfront, and let us know if you have questions.
Thanks, Amanda. So we did have one question come in, and I think it might be for both of us, but will we be emailed this deck or notes on pulling census data?
Yes, so we will make the deck available and we will link that on our site. We will also send it to you guys so you can share it. And I believe it's being recorded. So happy to share all of that. And if you run into issues finding that, feel free to email me here and I'll make sure you get that.
Thanks, Amanda. And as a follow-up, we'll be posting any links that we have on the website as well. And so you'll be able to catch the recordings of those, and any information that's being sent will be able to sort of post there. So
okay.
You will not be emailed directly, so reach out to either Amanda or, you know, to the website post session. So.
Okay, and I will note that I include my speaker notes. They will not match exactly because I don't read them at all really as I go through, but hopefully they also have tips in there too if you need them.
Great. So another question that came in from Eric, can you insert the census data directly into a shapefile?
Yeah, so that would be sort of the next two optional steps that I talked about early on. And your main thing you would need to go download the Tiger data, which is readily available in the census format. And then you would concatenate these three values. So in Google Sheets or Excel, you would just simply say concatenate, and then the order is important. You would want your state, making sure you keep a leading 0, like in California for 06, the county and the tract. So once you put those all together in one column, then you're set. You can just join it in. You can open that table in ArcMap and join.
Wonderful. Thank you. Great presentation. So on to our next, and if there's more questions, again, put them in the chat and we can get to them later. So we'll go ahead and introduce Lucy Guerra and Diana Lavery, who are going to be talking about Access Census 2020 Data with ArcGIS. Lucy Guerra is a product manager at Esri, focused on enhancing the user experience with quality data. She earned her bachelor's degree at UC San Diego. Woohoo! And Diana Lavery. Diana loves working with data. She's a senior product engineer on ArcGIS Living Atlas of the World's Policy Maps team. So go ahead. Thank you.
Hi, Amy. Thank you so much. Am I sharing my desktop or a slide deck?
We see your slide deck.
Oh, perfect. Excellent. Thank you so much. My name's Lucy Guerra. Thank you for the introduction, Amy. And as mentioned, both Diana and I work for Esri. And Esri is a mapping and spatial analytics software company, specifically that builds ArcGIS. And so what we are here to talk about today is how we can help you as users of ArcGIS work with census data. Now, unlike in the previous session, Amanda talked about working with ACS data specifically, and what Diana and I will be talking about is the Census 2020 data. So let's take that away. Okay, so the US Decennial Census taken last year counts every person in the US once, only once, and in the right place. And that resulting census data serves as a reset for data users as the most current and accurate picture of the US population. And Amanda alluded to this earlier. It's complete count data. So it's not surveyed, it's not modeled, it's a count of everyone in the United States. It also serves as a baseline for Esri's annual demographic updates. But today we're going to focus on the Census 2020 data. And because those data are inherently spatial, and because spatial data and maps just go so well together, Esri's committed to bringing this data to the community in useful ways. So our goal today is to share these with you so that you can get started working with the data using ArcGIS. But first, we're going to do a very quick review of the past 19 months. So earlier this year, Census announced that the total population of the US was over 331 million. So where did that number come from? And you'll remember in the spring of 2020, there was a lot of encouragement and messaging around participating in the census and filling out your form, whether that was online or on paper. And it asked 9 basic questions of you. How many people are living or staying in the house on April 1st of 2020? Is the house owned or rented? And then for each person in that household, their gender, age, Hispanic origin, race, and how they're related to everyone else. So after lots and lots of data processing, Census has released the data. And it actually gets released in 3 different phases. So in April, the apportionment counts were delivered. These were total population by state. And they were delivered on April 26th. Those are used for apportioning seats in the US House of Representatives. But the second phase are the redistricting data. And you may also hear these described as PL 94-171. These are the data sets that have recently been released. And Census is required to provide states with these local area census data for the purposes of legislative redistricting. It includes population by race and by voting age, as well as detailed group quarters information and some housing occupancy data. And that's all available down to the block level of geography. Now there is a third phase, and that's the demographics and housing characteristics. And these are going to be released sometime in 2022. And it'll be the remainder of that detailed information that'll include family type, relationship, housing tenure, and some of this information by major race and ethnicity groups. So that's the recap of Census. But let's talk now about who uses census data. And really the applications are quite broad. First and foremost, the data is used for redistricting to help states redraw electoral district boundaries based on shifts in population. Of course, the data can be used for elections as well. Now, commercial real estate and retail organizations will use this kind of data to help them identify a new site for a store or location. They may use the data to help them do market analysis, better understand a market that they're currently in or a market that they're looking to move into, and also perform target marketing, better understanding folks that come to their store or use their service, etc. The data is also used for transparency on public sector spending. It's used in advocacy for equity and social justice. Economic development organizations are using the data to understand how to better plan for their communities. It continues. Education, health, federal grants and reporting requirements. And then, of course, this data is used to understand our communities in the event of emergencies and disaster response. So that's how it can be used. Let's talk about how to access this data. So as mentioned, Esri is committed to bringing this data to our users because the data is inherently spatial and is really interesting to look at in a visualization use case. And so the first thing we did was in August, release all of the Census 2020 data through Living Atlas. And Living Atlas is a collection of authoritative data curated by Esri and made available for use by the public and for use within ArcGIS. So specifically with this Census 2020 data, you can access layers of this data for every state down to the block level of geography. And these are public layers. They're available to any user. So this means if you're using ArcGIS Online or ArcGIS Pro, you can just start working with this data now by adding it as layers from within Living Atlas. And Diana is actually going to showcase this in just a couple minutes. Now, in September, we released the Census 2020 data in a product called Esri Redistricting. And this product is a web-based software tool that helps governments work on redistricting plans. Esri Redistricting provides tools to create redistricting plans, management, visualization, editing, collaboration, and it helps to share this whole process with the public and maintain transparency. And then coming up in December, we're going to be releasing this Census 2020 redistricting data through our enrichment capabilities and in some products, additional products, Business Analyst and Community Analyst. And this is going to include not only the redistricting data, but some additional items alongside. So we're adding to the Census 2020 data by including Hispanic ethnicity by race. So adding on to total population by race and not Hispanic population by race. In addition, we're going to provide the population under age 18 by race. And we're going to include a couple of key totals from Census 2000 and Census 2010 so that you'll be able to do some comparisons. Now, why is this important? Census boundaries change every 10 years. So it's really important when you're doing comparisons between data sets from year to year that you're making sure you're using the same set of geographies underneath. Make sure you're comparing apples to apples. And in addition, this release in December is going to allow you to work with this data for non-standard areas. So for example, if you're working with a site and a radius around it, or a drive time, a 10-minute drive time around a site, or even a hand-drawn polygon or area or aggregations of standard geographies. So what I'd like to do right now is pass things to my colleague, Diana Lavery, and she's going to share how to work with these layers and what went into the creation of them.
Thanks, Lucy. All right. Let me know when you can see.
We got it.
Perfect. All right, so as Lucy mentioned, she had a slide on this. This is ArcGIS Living Atlas of the World, a collection of all kinds of GIS data, maps, apps, layers, 3D scenes, you name it. It's really a great way to bring content into all kinds of ArcGIS products. And so we have the Census Decennial redistricting data for a lot of those for almost all of the spinal geographies like Amanda was describing, as well as some of the key off-spine ones such as congressional districts. These are nationwide layers, but we know that redistricting is really a state-by-state exercise. So what we've done is create views off of the nationwide layer for each and every state. And I know this is the UC California event, so let's look at the California layer a little bit more closely. You can see that the item's description has all kinds of documentation, including how we processed it. Esri used the files made available by Census, but we've done a few additional things to it. Dropped some duplicative fields, for example, that were in different tables. When we merged it all together, you only need one of those kinds of things. We've also included very few calculated percentages that we know are going to be very popular in terms of how people are going to be using this data. To visualize it, because it is counts, population counts, we chose to symbolize that by size rather than a shaded color for the polygon. That's really better for percentages, but for counts, this is the way to do is the size. And now you heard from Amanda a little bit about the differential privacy aspect. What that means is that in my household, there are two 36-year-olds, one male, one female, and there is one 3-year-old female. Think about just in your block, what that profile is for you and how many other households in your block there would be of that profile. Probably 0. Then you add on the fact that they know that you rent or own, they know your race or ethnicity, they can get to you very, very quickly. So what Census has done is kind of fuzzed the data a little bit at the block group level. And then when you aggregate it up, you'll get an accurate picture. So what we did in our pop-ups is we aggregated up around the adjacent tracks. So the total population, that's what Census says. But all this detail here, it's performing a calculation on the fly to calculate this in combination with the adjacent tracks around it. So that's really kind of nice. Let's open up this layer and we'll work with it just a bit more. Say you were interested in mapping student population, university students in school housing. What we can do is search the attribute fields, which I'll do in a second here. Instead of total population, we want to look at the student population. All right, I think this is the attribute I want, but let me click on this information button and make sure. What we've done is included a lot of the metadata that came from census documentation here. So you can see exactly what student housing really means. You can also see a lot of the descriptive statistics here. So this looks great. I want to use this as my variable that I'm going to be mapping. Let's add that one more time. Student, there we go. All right, it picks up on the fact that this is an integer. And so it's already suggesting, hey, maybe you want to use size. Well, look here, apparently there is one block out there with 8,000 students. We're going to move this down a lot more, maybe to about 500. And we can even zoom in on the histogram a bit and see what this does. All right. We can even do 400 here. Why not? And we already see that here by Sacramento State, we're getting the student housing pop. Now, you're also probably noticing that under 50, that probably includes zeros. All these other blocks here with the smaller dot, that's not what we want. So we can filter out the blocks that have 0 student population. Search the field once again and say, is at least 1. There we go. Perfect. So that's Sacramento State. Now, if I zoom out just a bit and go down that Highway 80 west, I will come to UC Davis. And again, this looks good. So this validates what I already know. I think I'm in good shape here. So we've actually made a few different maps like this that I'll share with you guys. That first and foremost map of total population. We also have 18 years and over. And this opens on Washington, D.C. since that's our capital, but I know that Merced was actually really instrumental in setting up this event. So I'm sure there are a few UC Merced students here. Again, we'll just view the different maps. Here's total population 18 and over, that voting age population that is so important in redistricting. And again, clicking on the pop-up, we can get more information about this particular block, as well as aggregate it up with the adjacent tracks because of that differential privacy. And a few more maps. There's 18 and over, group quarters, which was mentioned earlier, housing vacancy, and then this one, predominant race or ethnicity. So this is showing the most common race or ethnicity in that area. And what I really like is that the pop-up contains the colors associated with the map. So here we've got a different block in Merced. We can see that this one, Hispanic and Latino. And if we zoom out, we'll actually get a multi-scale map experience. So here we'll zoom out to the county level, see a little bit of a different pattern here. And if we zoom out to state, you might not know the most common race or ethnicity at the state level. Any guesses you can put in the chat? For California, it is Hispanic and Latino, and just like the state of New Mexico. Texas was very, very close. That's why it's in a lighter shade of this tan color to indicate that it's close. So Hispanic and Latino was 11.4 million in Texas. White non-Hispanic was 11.5. So hence the very subtle transparency used in this map.
That's great, Diana. And I just, if you can go ahead and wrap up for both of you and we can get to our last presenter.
Sure, no problem. So we have a very similar atlas like this for all different types of race and ethnicities. All these maps can be found in Living Atlas. You can use them in any kind of ArcGIS story map or what have you. And then I also did want to plug the American Community Survey layers that we do have in Living Atlas as well. Thank you.
Great.
Thanks, Diana. Amy, we'll pass it back to you.
Thank you both. Any questions? I think we'll go ahead and put them in the chat. And if Lucy and Diana were okay, I see a couple of other notes, but we'll go ahead and transition over to Vince for the remaining time, and we'll handle any questions. So Vince, go ahead on geographic changes and comparability. And I'll say Vince is currently the Associate Division Chief over Geographic Standards, Criteria, Research, and Quality in the Geography Division at the U.S. Census Bureau outside of Washington, D.C. He was hired by the Census Bureau in 1997 at the beginning of the work on the 2000 census. Vince is also currently the U.S. representative on the United Nations Expert Group on the integration of statistical and geospatial information. So go ahead, Vince.
In trouble here. All right, now I'm going to share my screen. I know I'm limited to a short amount of time here. And now my PowerPoint went down. Welcome. Let me bring it back up again. Welcome, everyone. You guys hear me okay?
Yes, we can, Vince. And I'll let you know when we can see your presentation.
There we go. We should be good now.
Yep, we can see it.
All right. All right, so I'll be quick. I've got 10 minutes. So I was told it would be a lightning talk, so I should be prepared. Happy GIS Day and GIS Week. Thank you for inviting me. As you know, I think this dovetails well with the other two presentations. Census Bureau is a major creator and provider of data, especially geospatial data. And I just wanted to bring up this issue because I knew the people on here should be researchers, academicians, and GIS users, and hopefully future GIS professionals. One thing we always want to stress at the Bureau is GIS is a tool, a very powerful tool, but requires a lot of knowledge and experience of geographic concepts. And, you know, as a longtime GIS user since ArcGIS workstation, pull the software apart. Don't look at the routines and how they work. That would be some advice on my side. Don't assume how things work. And we know geospatial and GIS data has really opened up awareness of geography, and we tend to get more and more requests from data users, including statisticians at our own agency, that we include more and more geographic information. As you see, as a result, when we get down to smaller and smaller geographic areas, though, we have that balance with data privacy and disclosure, and why differential privacy is the latest flavor of that data protection. But one thing I wanted to point out here is there's been one of my challenges for my area, the Census Bureau, is how do we consider geographic change as there's more and more interest and pressure to be linking data sets. Geography tends to be an obvious linking area for that data. We provide the framework for how data is collected and tabulated and ultimately presented to the data users. You know, we've come up with more ideas and more work on this as more and more people are creating mashups and able to access more open source versions like R and QGIS, as well as the big powerhouses like Esri and the statistical software like SAS. What I wanted to bring up was how do we, when we're linking these data sets, how do we want to consider changing them? There's always been kind of an assumption from data users and statisticians that geography is in a way static, or they've chosen to ignore how fluid geography is as well. And so as statisticians, and I want to say statistical as in all tabular data sets, not just statistics per se. When they're comparing them, they don't think about necessarily the geographic aspect and change of that geography. So we're considering in this geographic change is we're in our MathTiger database, which we're taking care of, is there's hundreds of thousands, if not millions of changes over a decade, and thousands and tens of thousands at least per year, because our MathTiger database, our geospatial system is topologically integrated. So if a boundary is following a road, we store those relationships. So if a road gets rerouted, whether just a data correction or an actual change in the landscape, that relationship needs to be broken apart or maintained. And so there's a lot of work in that. So when most customers come to us, including other parts of the Census Bureau, they're like, oh, we want to know about all geographic change. And I'm like, no, you don't. There's far too much data for you to look at or to be useful. So then we have to get into the idea of whether a change is significant or substantial, especially significant in terms of the statistical data. Secondly, data users want to know about geographic equivalency, as I term it, but meaning what geographic areas are the same as another geographic area in the same data set, because there might actually be different data available for that same coverage. So like a school district is coextensive with a place, as mentioned earlier, a county. To build that knowledge into the data. Lastly is geographic comparability. At what point does, when geography changes, is it still comparable? Should it be compared? That's really the crux and the difficult question. I don't have answers for these since we're working towards it, but I wanted to bring up the ideas, especially to this community. I just have a few quick slides on general examples. So this is just in a place record. And you see the changes that happen one year as boundaries get updated. So the red is the changes. And in this case, it's obvious that the changes would not be what I would consider significant or substantial, and would still be comparable because very little housing and population is involved. Just as another example, this is another place, this one in Utah. This is what it was for the census, the 2020 census, but this year it basically doubled in size. So this shows both on top. I didn't have good imagery. The cloud cover was a bit much, so I used roads as a surrogate, but it shows basically that all the development and population was in the original. So a large area change geographically has little or no effect on the population and housing counts in that area. Are you going to cut me off, Amy, or do I have a couple more slides?
I'll let you go ahead, Vince. I know we got a little bit late start. We'll go ahead and keep the recording, but if anyone has to jump off, they can catch the recording post, but we'll let you go ahead, Vince.
Yeah, it'll just be a minute or two. This is just an example we've created on census tracts, as we heard both previous presenters mention them. The point of census tracts is that they're supposed to be as comparable over time as possible. But another big criteria criterion of the census tracts is that we try to get a specific number of housing units and or population in that area so that there's a level of statistical reliability in the data. With these conflicting uses, just in this example, so outside of Salt Lake City, in South Jordan is the name of the place in Utah, that in 1970, there was one census tract, 1130, and we tried to build into the numeric system of census tracts that as they change, they follow these same patterns, so there could be a forced comparability over time. So in 1980, it split due to population growth and local interest and more statistical resolution in their data. So they split it into a suffix of 1 and 2. Then the pattern continues over the years. As development in the area grows, it keeps going until 2010. We had 14 census tracts, it looks like. And no, actually, sorry, hey, 12. And then we actually, there's 14 now in 2020. I just looked before. But this makes it very complicated for data users because in certain really high growth areas like Maricopa County in Arizona, they ran out of tract numbers about 10 years ago. So that comparability gets broken through just the coding system. And that causes quite a bit of confusion for anyone who doesn't look at the spatial data like we do. So things we're looking at for this decade as well as tracking comparability and significant change is looking at data presented in grids so that we have another stable geography to look at. I think I'll just end with that at this point because I know I'm over time. But I wanted to bring these issues out there. It's one of the many puzzles we get to work on. So thank you much for your time and interest, and happy Thanksgiving and holidays to everyone.
Thank you, Vince. And I don't know if you want to pull up your last slide just to show your contact info or not. We can. Nobody. That's okay.
Yeah, you can share my contact info anytime. So
wonderful. Well, are there any questions that have come in? But I think this was a phenomenal sort of session. I'll say I did hear one comment that said that we should actually have this topic on an annual basis to be able to look at sort of the dynamics and everything around the census, and there's lots to explore. So yeah. I think Vince, you left us with some good thoughts of thinking about those geographies and really truly trying to understand those. So yeah. Okay. Well, if there's no more questions, I want to thank all of our presenters, give them a virtual round of applause for presenting and attending, and thank you all. And I think that concludes our UCGIS week for today. Happy GIS Day, and things will pick up again tomorrow, and you can find the schedule on our website. You can expand the links to find the Zoom links to join, and don't forget to fill out the survey code. So thank you.